I'm recording. Okay, I'm recording so that I can give this thing to you later as a MPEG-4 file, MP4. Now I'll teach something, and you see whether you understood those stuff or not. Okay. So first of all, we have the question about the rational numbers, which we say P divided by Q or A divided by B, we write it, and P and Q are coprimes. So coprimes means they have only number 1 as a common factor, and other than 1 they don't have any other common factors. Then we consider that number as a rational number. So the examples we talk about is say 1 by 2, 3 by 4, 7 by 5. All these, they are coprimes, so rational numbers. Even though we write 3 over 6, it's a fraction. There's no doubt about it. It's a fraction. But when we write it as a simplified or the simplest fraction, which is 1 over 2, this is rational number. But in this form, it is not rational number because 3 is a common factor. Exactly, simplified form. Okay. Now comes to irrational number part. Okay. So before we go into the irrational number part, okay, you look at certain things in physics or physical quantities. Okay, we all live in the world where we may have to see either measure or a count. Okay, we end up doing either a counting or a measuring. So we use this for some time, we use this for some time. Okay, when we are looking at a counting, for example, you can just say count a number of people, okay, or you want to say how many kilometers, okay, to a whole number you can do that most of the time as a whole number, or as a natural number if you are using only from 1 to 1 onwards. This is 0 onwards, correct? So these are all the things that go with the counting. When we say measure, when we are doing measure, we have some tools or devices to do the measurement. So for example, tool, yeah, it's measuring instruments and all the things. So you have a ruler. Okay, so the ruler what you use in the school or for all our construction. Okay, if I ask you, can you draw a line with a length of 15.234? Let's suppose I ask you to draw a line with this length. You may draw a line, okay, approximately you will draw a line, okay, and then you will say I want to start with a ruler. Okay, so you try to do with this a ruler, for example, and okay, so just put a ruler here. So you want to measure this, for example, right? And it says 25 point something or whatever. Okay, this line length is 25 point something. Okay, but I cannot actually, I reduce this and I will draw another line in order to say, okay, so I'll start from here and I go up to 15, right? 15.2. I stopped it. How do I get this much kind of, how do I get 234 into that? So 234. So this tool or the device, okay, will affect how much you do the measurement. Exactly. So this measurement, whether it's accurate or precise or whatever you call it, right, it all depends on what tool you are using. So the measurement word is always is not a perfect thing. Okay, count word is always a perfect. You will get somehow the whole number, right? Okay, so this measurement things is the one which is actually the controlling in the world. Approximations, you rounding offs, and all the things. Okay, so this is the one which actually rules the entire stuff what we experience. So why I'm saying this? Now come back to, there are certain things, the numbers which are perfect squares. Can you tell me what the perfect squares are? 4. Okay. Okay. And so on. That means you take square root of the perfect square, you will get the answer either plus or minus something. So this, yeah, whole number. Okay, so you get a something like a whole number you will get. So if you do not have a perfect square inside this, that means you have a non-perfect square. So that will give you an irrational number. Yeah, as long as you don't have these numbers, right? That means if I have root 2, is it irrational? Yes, it is irrational. This is one of the very loose definition of one of the definitions of irrational numbers. Okay, yeah, these are the one type of irrational number. The other type of irrational number is the one when you actually convert into a decimal form of a fraction. Okay, decimal form of a, for example, a rational number, and then it doesn't terminate through a long division. Okay, and that particular thing is also an irrational number. What is the rationale behind that definition? Because you don't have that perfect measurement, right? So this is the reason why the ratio of the circumference, right, circumference to, yeah, okay, I'm not reading the text. Yeah, true, this is the same example actually. So these are the two definitions. Okay, next I think we may have to send, you may have to send me the pages, which one to cover, because it's a new book, right? New book, new print. Yeah, new print, right? Is it this year's edition? Yeah, yeah. I don't have this year's book. Okay, that's why. So, so these are the two definitions. Okay, these are the two definitions. Pi is the coming from this does not terminate, and the other one is a non-perfect square. Okay. So understood how this definition of the irrational number coming into picture? Yes. Now, the next point is, what are the properties, or we can say what are the operations you can do, operations on these irrational numbers. What do you mean by operations? Yeah, addition, subtraction, multiplication, division, and if you have a square root or whatever, so on, right? Now let's look at the addition properties and subtraction properties. These are together, and this we'll cover separately. So the representation of, when you represent this like 2 plus 3, we know it is 5 because you are adding two rational number additions. Two rational numbers or whatever, okay, or you say whole numbers, not a problem. So if I have to add 2 plus root 3, right, without changing this, without actually finding out or anything, its answer is 2 plus root 3. No change. Okay. So if you are adding a rational number and an irrational number, okay, so you are getting an irrational number only. Same thing goes with the subtraction as well. You understood this very well? So that's the first set of operations. Now comes the multiplication. So when I am doing the multiplication, so I multiply, for example, okay, before that I need to explain here what happens if I add two irrational numbers, right? So this is irrational and this is irrational. They still they still remain same because both are two different things. But if you have root 2 plus root 2, you will get an irrational numbers 2 root 2. Hello, no. 2 root 2. 2 root 2, okay. So irrational plus irrational, you will have irrational number. Alright, so this is how the addition as well as the subtraction also will remain same. In case of subtraction, you get 0. Okay, this subtraction will just as a subtraction, same thing. Okay. Now comes to multiplication. Again, multiplication with a rational number with an irrational number. That means 2 multiplied by root 3. Okay, yeah, 2 times the root 3. 2 times root 3. So it's again irrational number. Good. So if I have irrational number multiplied by irrational number, so the same thing like the way here, right? So two different things can happen here. You can have a rational number or you can have an irrational number. How? Yeah, both are possible. Okay. Oh. Exactly. Root 6, correct. That's an irrational, right? So the result is what we are actually seeing. One is, as you said, root 2 into root 2 is nothing but root 2 squared, which is nothing but 2. Yeah. If I have, on the other hand, root 2 or root 3 into root 2, I'll have root 6. Okay. So it is still an irrational number, and this is a rational number. So now the division is one of the important properties of irrational numbers. Very, very important. Okay. So before we go into this, any number, anything, you divide by 0. And this is what we say? No, undefined. Yeah. Yeah. Why? Because when we say 1 over 2, that means you are dividing 1 into 2 parts. Okay. So it makes sense. 1 is divided into 2 parts. Okay. You have 3 and dividing with 4. So you are dividing 3 numbers or 3 parts. You have 3 parts like that. 1, 2, 3. You want to divide them into 4. Also makes sense because this is a finite number. Okay. You cannot divide anything into 0 parts. That's why it is not defined. Okay. So why we are talking about this thing? The denominator, this plays an important role. Plays an important role in the division, because division is after all with the denominator only we are doing the division, right? And therefore what he tries to say is that there is certain things we need to do when we are talking about the divisions. So if I have root 2 divided by 2, it is irrational divided by rational, it still will be irrational, which is 0.5 times of root 2 or half of root 2, not a problem. This is easy because this fellow is a finite whole number. It's a whole number, or we can say it is a rational number, so not a problem. Okay. So now if I have root 2 by 2, if you are asked to simplify, then you can't leave it. Okay. Oh, good question. This is root 2 by 2, meaning root 2 by 2 means 1 into root 2 divided by 2. That's half into root 2. That's why you get 0.5 root 2. Got it? Now, if this, so this is also not a problem. But if we have the other way, 2 divided by root 2, So in such a case, you are having a rational number by irrational number. So when you have these things, we must rationalize the denominator. So we can't decide without getting into this form. We have to get into this form. Okay, that is when you can decide. That's what the important step in this, rationalizing the denominator. Okay, so you are converting the irrational denominator into a rational. How do we do that? It's very simple. Okay, this process they explained in the class. Oh, you didn't start yet. Okay, so multiplication and stopped. Okay, that's the reason I said, in the multiplication, right? That's in the multiplication. Yeah, yeah. So I will cover that after this, or during this I will cover that. Okay. So what do we mean by rationalizing? See, I explain this process in this way. So I write this 2 divided by root 2 plus 0. I'll write it as root 2 plus 0. Then this is same as that. Okay. Then I do multiply with the change in the sign. This is very important. You must remember, whenever you will get doubt afterwards when the school covers this. So this is what I need to do. So I do the multiplication of the numerators, which means 2 into root 2 minus 0 divided by root 2 plus 0 into root 2 minus 0. So this, you open a bracket, you get 2 root 2 minus 0 divided by this. Always in the rationalization you will get a plus b into a minus b, which is your favorite formula, right? What's a plus b into a minus b? Okay, so a square is root 2 square minus b square equal to 0 square. So 2 root 2 is a numerator. Denominator will be 2, correct? Minus 0, it's 2. So this 2 gets cancelled. So the answer is root 2. This is irrational. Correct. So in fact, for any number divided by root n, the answer is root n. Okay. So what we did, no, n has to be same. So your question, n has to be same. N is ah, ah. Okay. Now let's try a few questions. Okay. So we have 1 by root 5 and 2 by root 7 and 3 by root 2 plus root 3 and 4 divided by root 3 minus root 2. So all these things we need to do now. So I have two choices. You work it out right now in the notes. Okay. If you have a phone with you, you can WhatsApp the answers. If you don't have phone with you, then tell me the answers. I will see whether it's correct or not. All right. So start the first question. So what is the question is rationalize the denominator. That's the question. Rationalize the denominator. Okay. So it's going to be root 5 by 5. Correct? Yeah. So the first one, I'll write it in a special ink. So your answers are root 5 divided by 5. Okay. Then next one. So 2 root 7 divided by 7. Yeah. Next one, you may take some time. Fine, but 3 times root 2. Then by 5. Okay. You're seeing the board? Okay. So this particular thing you have to multiply with the opposite sign. We have plus here, you multiply and divide with the minus there. Yeah. See, you see here, previous page I am showing. If it is plus here, I multiplied with a minus 0. Okay, so I will put it here. Observe this sign. Observe or not. Okay, so whatever is there, if plus is there, minus, if minus is there, plus, like that. Okay. So tell me what's the answer. Yes, yes, yes. Divided by. Yeah. So either offline or online, it is Chetas. Okay. So you do so fast. Minus 1. Correct. Okay. Now go for the next one. 4 times root 3 plus 4 times root 2. That's it, right? This is the final answer. Okay, it's correct. So this is how we do the rationalization. Now we went with the simple things. We just have the denominator such as a simple thing like that. Okay, so we can have both numerator and denominator with, so I'm giving you another set of questions. Okay, the set of questions are now root 3 plus root 2 divided by root 3 minus root 2. This is one question. Next question, root 7 minus root 2 divided by root 7 plus root 2. Okay, do this both questions again. So this is where you will use whatever they covered in the school, right? Multiplying that a plus b whole squared, all that stuff will be coming now. Okay, that's what I said I'll be teaching in this actually. For this one, is it? For the first one, 5 times 5 plus 2 times root 6. This is the answer. So you did basically root 3 plus 2 whole squared. So 3 plus 2 is 5 and root 6 is correct. Yes, correct.
So 9 minus 2 times 14 by
9 minus 2 times of 14 by 9. Okay. 2 times square root is there or no?
square root.
2
Square
times
root of
14
14.
and divided by 9. Is this the way you are saying?
Yes, sir.
Okay, correct. So Do you think you can represent them on the number line? Is there in the textbook?
It's there in the text.
Textbook representing these numbers on the number line?
Yes, sir, it's there.
It's there. So what is that they mentioned? So how do we represent root 2? So I'll,
It's there for a rational. Oh, it's there for a rational.
rational, not for irrational number, right?
It's there for a rational.
Also, okay. Before that, there is something called inserting, isn't it? Insert rational, irrational numbers between. Is there a question on that or no? That's the next exercise, I think. There is no insert. Inserting rational numbers. Huh?
Last year we done it.
So now they have not included, right? Okay. So the rationalization, you have some tougher questions in the textbook than this.
For irrational numbers.
Yeah,
I know, sir, there are no tougher questions. All easy questions.
easier than this.
It's always just, yes, only 3, 5 and 2 are used.
Okay. Yeah. So 3, 5 and all these things are used like that now. Okay. So general information on how these rational numbers are in fact so if you have a square, for example, so entire geometry, whatever we think is a perfect, right, is all run on this actually. Okay. So assume this is a square. Okay. So let's suppose we have a square here. This is a square, and this is obviously a whole number, or it can be any other number. Generally, whatever we can represent, if not whole, we can probably use a ruler, and then based on that precision, we can write it. Okay. Surprisingly, when we try to actually measure this diagonal, right, is not so perfect. You know why? Perfect means it's a definitely diagonal is irrational number. Perfect, I mean, is irrational number. Irrational number automatically, okay, whenever we say irrational number, you can't measure this precisely. Okay. Why is it like that? Because always the square will have two right angle triangles. Let us take the first right angle triangle. This side right angle triangle is there. Okay, let's take this right angle triangle. Okay, say this is 90 degrees, for example. This is not to scale, it's 90 degrees. So if it is a square, then this is for example 3 centimeters, this is 3 centimeters. So this will be square root of 9 plus 9, 3 square plus 3 square. So this is square root of 18. So it is not a perfect square. So yeah, you will get 9 root 2 actually. So you always have, if this is a and this is a, you will have a root 2 is the diagonal. But what happens in reality, we try to go and buy a huge TV you want to put in your movie room, and you try to see on internet, Amazon or wherever. Okay, they will just say you will have some 52 inches, right? 52 inches TV, measure diagonal. Okay, yeah, diagonal is that 52 inches. So definitely if it is a square, he cannot have a perfect measurement. If it is not a square, you have a rectangle. For example, you have a rectangle. Then you may get a perfect square. I'm coming to that. So for example, this is 24. I'm sorry, this side is 24. For example, this is 24 centimeters. This is 7 centimeters. Can you tell me how much is the diagonal? Root of 24. Root of 24. Pythagoras theorem. Abacus. I'm teasing you. Abacus. Fast. Square root of that. 25. Okay. So you're getting 25. A whole number. So only if you are having squares, and when they say that I am measuring diagonal, you have to be careful, because you will not be giving a precise thing. But for non-square things, that means you have a rectangle, you may get a precise number. Okay. That's why you don't have TVs or the suitcases or anything in a square shape. Uh, but then you may get a rational number, but not irrational number, so that it is measurable. Nobody will sell. Measurable with available tapes and rulers. Okay. Otherwise, people will not buy that. They can't actually trust that, right? Okay. So that's one. The same logic holds good even if you have a three-dimensional shapes. Okay, you have a three-dimensional shape. Okay, so this is a cube. Assuming this is a cube. So if it's a three-dimensional, then there is something called a principal diagonal. Okay, so from the lower bottom to the upper bottom, like from here, so up to this. Okay, so when we are measuring this diagonal, actually what happens is it actually comes like that to the bottom. Okay, so that's when you are actually doing this. Okay, this is the triangle. Okay, here no problem, because you are having one diagonal and one side. Okay, so this particular thing is irrational, but the moment you square it, you have to remember what I am saying. Okay, even if I have, it is like a 4 root 2, and this may be 4. So this is 4 root 2, this is also 4, that means this is 4. So you are doing 4 root 2 square plus 4 square. So this is nothing but 4 square, 16, 16 multiplied by 2, 32, plus 16, so 48. Okay, now 48, is it a perfect square? Is it a perfect square? No, because it's a 4 root 3. 4 root 3. Okay, so wherever you are getting this kind of a diagonals, you will see if it is not a perfect square, automatically the irrational numbers coming up there. Alright, so geometry, of course all circles, okay, any circle if you say, and you are trying to measure the circumference of a circle. Circumference. So you go with the formula 2 pi r. Okay, so this, unless r is equal to, if r is multiple of 7, if it is a multiple of 7, that means you have 2 pi into 7 or whatever 7n. Okay, Then what? How do you do? 2 into 22 by 7 multiplied by 7 into n. Okay, 7 gets 44n. So depending on n equal to 1 or 2 or 3, you will get a whole number. This is how you will actually see in your mensuration questions. Most of the time they say the diameter is some multiple of 7, okay, radius is multiple of 7, okay, so that you get a whole number as a circumference. If in the event you do not have this radius as a whole number, sorry, as a multiple of 7, the circumference is actually depending on how or what kind of a precision tool we have. That decides the accurate value of it. Okay, understood? Not always. If r is not multiple of a 7, then it is irrational. If r is not multiple of 7, definitely it's irrational. Why? Pi is irrational number, right? Pi is irrational. Okay, that's the reason we talk about the circumference. Okay, or wherever you are seeing the spherical thing, you are talking about a sphere, for example, or you are talking the base of a cone. Okay, these are all the circles, right? And then you talk about cylinder. So cylinder surface area, or you are talking about the volume. Okay, in all these measurements, okay, you are bound to get this pi. If the radius is not a multiple of that 7, you are bound to get a irrational number there because of the pi. Okay. Okay, so this completes our part into the entire rational irrational numbers. Okay, where else you think irrational numbers come into picture? And by the way, this sometimes when we write like this, right? So you if you use a calculator, then calculator will approximate this as 2 plus 1.732 up to 3 decimal places, and you get an answer as 3.732 with a calc. If you are not using calculator, right, so then you have to do the finding the square root of 3 with that method. Remember, how do you get the square roots, right? With the dot method. You'll say 1 times 1. Okay, so 1 is there, then you have 2, then 2 point. Understood, right? So you'll have 0 here. Okay, so that's how this 1.732 will come into picture. What is to be done next? How do I get 7? Oh, forgot, is it? Ah, see, 28 eights are 8 eights are 64, 8 twos are 16 plus 6 224. So 27 sevens will go. With each decimal, you get 2 zeros. Now you understood? So you may have to do, yeah, you may have to do either this with a no calculator, or you can leave that same thing, and leaving like this is called surd form. Surds. You know it or you don't know it? It's not come to it, come to that point yet. So this is called a surd form. Okay. So without finding out actual final value, you leave the answer in a surd form and all. And this particular thing is international. You mean all other countries, right? So they will be talking about the surd form and all. You don't have this in the CBSE. CBSE, they don't actually cover this. Okay, so this is important. You need to understand, and you need to see if something is to be left in a surd form or something like that. All right. Okay, so what time is it? Wow, we have half an hour more. Half an hour more than up to 7 o'clock we are going, right? So you have more questions to be done. Then why don't you do that as a homework, the remaining things in your exercise? And any worksheet the teacher has given?
From the textbook only she had sent some finished all of them.
You finished all of them?
Last year, yes, sir, last year's concepts.
Okay, so this on this new topic like rationalization and all they have not given, right? So you have a class tomorrow, no? Tomorrow maths class is there. She may that's why tomorrow she may cover, she or he may cover
Next,
search and rationalization. Yeah, I am covering the third name afterwards because you will be worried about or to be worried about the name third only as a result of that operation. Like when you add, what do we get? Okay, so when you add two rational numbers or when you add rational numbers plus irrational number, so what you get is called a third form. Okay, these are called the thirds. Okay, so
irrational, it's a short form, which is 3 because
yeah,
times I
yeah, yeah, correct. It can be 2 root 5, 2 root 3 or 2 plus root 3, 2 root 5 or 2 plus root 5. Okay, that's the one. But then we won't, remember that we won't leave. For example, you have a huge thing like 2 plus root 3 divided by 2 minus root 3 multiplied by 4 plus root 5 divided by 4 minus root 5. You did whatever. Okay, finally you got answer. Then you make sure that the denominator is rational. Your final answer must be this, definite, whatever you do. Okay, why I am saying this is, yeah, the same question. No, third form is there. No, denominator should be rational. Understood, right? Let me do the same question. Let me do the same question the next page. Two ways of doing it. Okay, we have 2 plus root 3 divided by 2 minus root 3 into 4 plus root 5 divided by 4 minus root 5. This is what we have. So you can straight away do the multiplication here and you get 8 plus 2 root 5 plus, okay, 2 root 5 plus 4 root 3 plus root 15 divided by, I'll tell you what I'm actually coming to. Then you have 8 here, then minus 2 root 5 minus 4 root 3 plus root 15. Okay, then if you combine the rational and irrational parts, 8 plus entire thing 2 root 5 plus 4 root 3 plus root 15 divided by 8 minus, you take the minus common, 2 root 5 plus 4 root 3 minus root 15. So this is irrational part, this part. So this much you can go. We can't simplify this further. Why we can't simplify? Because the third is coming here, right? Let's suppose I do the other method. I rationalize. I get 2 plus root 3 whole square, and for this I get 4 plus root 5 whole square. I'm skipping a step. Okay, so this is one method, this is other method. So when I multiply this here, when I square it, I get 4 plus 4 root 3 plus 3 multiplied by 16 plus 5 plus 8 root 5. So is there a denominator? No. Okay, now if I multiply this, 16 fours are 64, so 64, and you have 4 plus 4 5s are 20. I'm just doing the dumb calculation, plus 32 root 5 plus 4 root 3 if you do. 21 times 4, 84 root 3. And that's what I did here. Then root 5 root 15 plus 32 root 15. Then you have 3, so you get 48. 16 for 21, 21 3 so 63. 63 plus 24 root 5. So you have root 5 and root 5. You will add these two. You may get 56 root 5. Then you have 84. 84 plus 63. So 84 plus 63 is 147. And so on. So you tell me, is this answer better or this answer better? The second one, right? Why? Because you in the denominator you still have an irrational part. So we can't have a question saying, is there anything wrong if I do this? Okay? It is not wrong, but it is not complete, because we need to have the denominator to be knocked out. Knocked out, I mean rational. It has to be a rational number. Okay. So that's why you need to be remembering, however big or small this is, you can be doing like that. So I'll give another simple question. How much is the answer?
So 5 plus 2 is 6.
This is the answer. Correct? Yeah, 3 square, root 3 square plus root 2 square, 3 plus 2, 5, and then you got root 2 into root 3 times 2, so 2 root 6. Correct answer. So we don't need to have here root 2 minus root 3 or whatever. In that case, you will get a minus 1, right? Okay. Yeah, good, correct. So now yeah, do these questions.
So the first one is x plus y
Hmm.
plus 2 root xy by x minus y
X plus y plus 2
plus root xy
divided
by
by
x minus y.
x minus y. Okay, correct.
3a square plus 2b square plus 2ab
Here 3a square,
plus
3a square plus 2b square.
2ab root 6
Divide by.
by 3a square minus 2b square.
Correct. Yeah, these three.
So the first one is a square plus b
A
plus
squared plus b plus 2a
a root b
root b,
by a square minus b.
a squared minus b. Correct.
The second one answer is x plus 3 root x by x minus 1.
X plus
3 root x
3 root x.
by x
How did you get that?
by x minus 1.
This is x minus 1.
Yes, sir.
This is the one.
Yes, sir.
How did you
So
get this?
it's actually x plus 1. It's actually x plus 1 plus 2 root x.
But you told me 3 root x.
Sorry, sir.
Huh? So the x plus 1.
Plus 2 root x.
This is the one, right?
Yes.
Okay, next one. Now this is correct.
Next one is xy plus 1
xy plus 1
minus 2 root xy
hmm.
by xy minus 1.
Correct. So
So the answer is for the first one.
hmm.
245 minus 60 into 5 by 205.
By 205.
Yes, sir.
So 245, 225 plus 20. So 245 minus 2 root. So 30 into 2 is 30, 60 root 5 is correct. Yeah. Yeah. Next one. How will you do this actually? It looks tough or easy?
Looks easy.
Hmm.
Can you find the LCM?
Yeah, you can. You can do that, definitely. You're not getting it. Again, the typical Chetan style. I'm sorry, Chetan style. Okay. So first one, either you can do this method like method one. As you said, you wanted to take LCM. Yeah, you take LCM, you'll get root 10, and you get root 14 plus 5, isn't it?
Yes, sir.
And do a rationalizing now, which is simple. So root 10 divided by root 10 Yeah, minus 0, of course not required. I mean, so now denominator becomes 10 and this becomes root of 140 plus 5 root 10. Okay, so you can leave that in the third form. This is method number 1. What's method 2? Method 2 would be, so how do we do method 2 here? This becomes root 7 into root 5 divided by 5, rationalize this, plus root 10 divided by 2. Okay, then you have 10 already here, so this is 2 root 35, okay, plus 5 root 10. Second we didn't understand. We rationalize this, same thing, I multiplied divide. Yeah, so you get the same answer actually. You take this 32 inside, you get 140 plus 5 root 10. Okay, so both methods you can do. Okay, so these are the actually some questions they keep giving. Okay, so let's say you have root x divided by root y plus root y divided by root x. So root xy, okay, then you have x plus y. Okay, so only the denominator is a problem, so you will just multiply with the root xy, so you will have this divided by xy. Then if you still want to simplify, then you will have x by xy plus y by xy, so that gives root xy, so x gets cancelled, 1 by y plus 1 by x. Okay, this is the answer. If you have the minus there instead of plus, if I have minus here instead of plus, you will have 1 by y minus 1 by x. So everywhere where you have plus, you will get minus. Okay, these are like not given in the textbook, but interesting questions. These questions can actually, easily done. People have to just think a little extra, and you will be able to get these things. Okay, so these are like quadratics. Whatever you do in a quadratic is a very similar. You have got this, and this is a reciprocal of this. Okay, so that's how you will do that. Okay, so in other words, if I have a similar concept, so if you remember this, so root 3 plus 1 by root 3. So this is actually, you take LCM or whatever, you will have root 3, 3 plus 1. This is 4 by root 3. Then rationalize it. So you will have 4 by 3 root 3. Okay, so it's the same as thing. You have a root x divided by root y plus root y divided by root x. So what we got was root xy 1 by y plus 1 by x. So this is the x and this is the y. So that's a root 3, that is this root 3. Okay, 1 by y is 1 by 1. Okay, plus 1 by 3. Okay, 1 by x, x is 3, right? So you'll have 4 by 3. So 4 by 3 into root 3. So that's why you remember this general formula, you can get the straight answers. So these are like, when you're preparing for all that engineering entrance examinations, right? So they start coaching from the 9th standard onwards. So these are the tricks. So whatever we learn in earlier pages are purely from the textbook. So these things are the tricks. So you know the normal thing what is given in the textbook, but you think little bit extra, additional thing. So these are called the higher order thinking questions, HOTS. Higher order thinking questions, higher order thinking. Okay, so that's how we should be doing those things. Okay, so still have time. Good, another 10-15 minutes is there. Okay, so in the language of chemistry, we're talking about chemistry, right? In the language of chemistry, so what did they